Hello everyone. Switching the main transformer is a very complex and important job. What problems may occur during the operation of the transformer? Let's learn it together. First, excitation inrush current of transformers. The concept of the excitation inrush current. The excitation inrush current of the transformer refers to the transient current generated in the winding of a transformer during full voltage charging. When the remaining magnetic flux in the iron core before operation is the same direction as the magnetic flux generated by the working power supply at the time of transformer operation, due to the total magnetic flux far exceeding the saturation magnetic flux of the iron core. The characteristics of the excitation inrush current of the transformer. First, the magnitude of inrush current is related to factors such as the phase angle of the power grid, transformer core, residual magnetic flux, and power system impedance when the transformer is put into operation. The maximum excitation inrush current occurs at the moment when the voltage passes through 0 point as the transformer is put into operation. At this moment, the magnetic flux is at its peak, and the inrush current contains DC components and high-order harmonic components, which decay over time. The decay time depends on the resistance and the reactance of the circuit. Generally, for transformers with large capacity, it's about 5 to 10 seconds, and for transformers with small capacity, it is about 0.2 seconds. There are discontinuities between the waveforms of the excitation inrush. The adjustment of tap changer for transformer. The adjustment of transformer's tap changer can be divided into two methods: on-load adjustment and off-load adjustment. The adjustment of the no-load tap changer of the transformer can only be carried out after the transformer is powered off. The adjustment of on-load tap changer switch with voltage regulation. The adjustment of the on-load tap changer of the transformer can be carried out during the operation of the transformer. Attention should be paid when operating the on-load tap changer switch. First, the dedicated tap changer operation of on-load voltage regulation should be carried out according to the voltage curve and dispatch command determined by the dispatch department within the allowable deviation range of voltage. The adjustment of grid voltage of 220 kV and below should be carried out by reverse voltage regulation method. Second, the tap change operation must be carried out after one tap change is completed before the second tap change can be carried out. During the operation, the indications of the voltmeter and ammeter should be observed simultaneously. Third, when two on-load tap changers are operating in parallel, it is allowed to carry out tap conversion operation at 85% or less of the rated load of the transformer, and two consecutive tap changing operations are not allowed on a single transformer. Fourth, when multiple transformers running in parallel are in step-up operation, the one with relatively low load current should be operated first, and then the one with higher load current should be operated to prevent excessive loop current. The sequence of step-down operation is opposite. Fifth, when the on-load voltage regulating transformer and the non-excitation voltage regulating transformer are running in parallel, The tap power supply of the two transformers should be as close as possible. Sixth, the change numbers of tap changers within 1 day shall not exceed the following ranges: 30 times for 35 kilovolts voltage level, 20 times for 110 kilovolts voltage level, 10 times for 220 kilovolts voltage level. Seventh, each tap change operation should check the gap between the system voltage and the tap voltage to make it comply with the regulations. Eighth, it is forbidden to adjust the tap of main transformer above the load and the voltage level specified by the transformer manufacturer. Third, the parallel operation and load distribution of transformers. First, conditions for parallel operation of transformers: equal transformation ratio, equal short circuit voltage, and same winding wiring group. Second, when the transformation ratio is not equal, the secondary voltage of the transformer is unequal. The transformers running in parallel will generate a balanced current in the closed circuit of the winding. The direction of the balanced current depends on the secondary output voltage of the transformers running in parallel. The direction of the balanced current is from the transformer with high secondary voltage to the transformer with low output voltage. In addition to increasing the loss of the transformer, when required to carry a load, the balanced current is superimposed on the load current. A transformer with balanced current in the same direction as the load current increases the load, and a transformer with balanced current in the opposite direction of the load current reduces the load. Third, when the short circuit voltage of transformers running in parallel is equal, the distribution of power for each transformer is proportional to the capacity of the transformer. If the short circuit voltage of transformers running in parallel is not equal, the power distribution for each transformer is inversely proportional to the short circuit voltage of the transformer. Transformers with low short circuit voltage are prone to overload, and transformer capacity cannot be fully utilized. Fourth, when the transformers with different wiring groups operate in parallel, and the secondary circuit generates a large phase difference and circulating current due to the different phases of the secondary voltage of the transformers. In severe cases, it is equivalent to a short circuit. Fifth, when the transformer of the RAIN network system is operated in parallel, the charging terminal should be correctly selected to reduce the voltage difference at the parallel place. In the future, everyone should pay special attention to the above issues in your work. That's all for today's lesson. Thank you.